Okay, let's talk about statistics. Oh, thanks. All right, so we're going to talk more about transforming of the parent graphs. Yes.
Do I get something for figuring it out?
No.
5.5?
No. But thank you. I appreciate it. All right. So, guys, quiet, please. I'm starting the lesson. Okay. So, in geometry, you call the transformation figures translations, reflections, rotations, dilations. So, this is stuff you guys have done already. Just so you know, translations means this: going left or right or up / down. So that's what a translation is. A dilation is when you stretch or compress. A reflection is when you flip about the x-axis or even y-axis. You could do that too. That's a possibility. I'm not sure how rotations would make sense for us, so I'm not going to really make a statement about that. But you would have seen these transformations, right? Like we've done translation, we've gone left or we've gone up and down. We've flipped over the x-axis. We've stretched the graph or compressed the graph vertically. So look at part A. What kind of geometric transformation have you made when you replace f of x with f of x plus k? This is going to be a translation of k units either up or down. So when you add something to the outside, it causes the graph to move up or down, but we call that more specifically a translation. You're translating the graph, we're going up or down or left or right. In this case, because k is on the outside, we're going either up or down, depending if k is positive or negative. Obviously, we go up if k is positive. We go down if k is negative. So if k were a negative value, you go down. I think that's as specific as I can be with that one. Any questions on part A? So again, if you're adding something to the outside, we call that a translation. And it's going k units either up or down. K is positive up, k is negative, go down. Okay, let's move on to part B. What would you call that when you have a negative on the outside? Of those terms and quotations up above, when you have a negative on the outside, is that a translation? Is that a reflection? Is that a rotation? Or is that a dilation? So reflection, right. And let's switch colors for a bit of contrast. So for part B, that's going to be a reflection about the x-axis. We have negative out front. What about the minus h? What do you think that does? What does that do, guys? Or what direction could it go in? Not up, left or right, exactly. Depending on what h is. So we call this a translation and how did I say the other one? Hold on. Just want to be consistent. Give me a sec here. Oh, there we go. Okay. Yeah, that's a translation of h units either right or left. If h is positive, you go right. If h is negative, you go left. So depending on what value h holds, like if it's x minus 1, then h is positive 1, then you go 1 right. If it's x plus 1, and h is negative 1, then you go 1 left, right? I mean, correct, sorry. Should be careful my word choice. So that's what that represents. For the next one, what does this a do over here? What do we call that? Using the terms of dilation, yes. That's a dilation by a factor of a. And more specifically, it's going to be stretch if the absolute value of a is bigger than 1. Or it's going to be a compress if A is between 0 and 1. That'd be a compress. And by the way, if it is a compress, then you're going to say dilation by a factor of of 1 over A. So I want to be clear about that. Because what if you have like y equals 1/2 x squared? Then you'd say vertically compress. You don't have to write this down, just for reference, by a factor of 2. Because 1 over 1/2 is 2. So you want to say compressed by a factor of 1/2 because that's kind of a double negative, or it's kind of weird to say it that way. So you want to say it's still compressed by a factor of 2, even though you multiply by half. So be mindful about that. Okay, E. I haven't taught you guys this one yet. This is a new one for you guys. Okay, when you have negative x on the inside, that's going to be a reflection about the y-axis. Let me give you a good example. Actually, the examples are down below. Okay. So here's what we're going to do. We're going to do f of negative x. Let's do the parent functions first. Then right below, I'm going to write this. And let's draw coordinate planes. Okay. Then how do you guys copy this down first? So f of x equals x cubed, f of x equals x, f of x equals 2 x, f of x equals f is 1 over x. And replace all the x's with negative. Put them in parentheses just to be on the safe side. Don't mess it up. Now, I'm going to go to Desmos. I'm going to graph each of these, and we're going to see what happens. Okay? But let me wait for you guys to copy first. Now let's go to Desmos, let's do a little exploration, and then we'll come back and fill out these graphs. Let me know when you guys are ready. Okay, ready? Okay. I'm going to clear my drawings for a sec. I'll bring them back. Let's go to Desmos. Here we go. Okay, guys, quiet down, please. So y equals x cubed. We know it's this, right? What if I did this? Y equals parentheses negative x. So what happened? It reflected, right? Now, here's the thing. It's the same thing as saying this. So we know the green and blue are actually coincide with each other. We know that the negative in the front flips over the x-axis, but the negative on the inside flips over the y-axis. So let me close that one down. So you can see how if you flip the red over the x-axis, you get blue. But what if you flip the red over the y-axis? The same thing, right? So you still get the same thing. if you flip over the y-axis, you still get y equals negative x cubed. So that's what's happening there. What was the next one? Was a square root? What's the next one, guys? Yeah, square root. Okay. Here's what's gonna happen with this one. I'll do square root x, and then let's do square root negative x. Okay. See what happened? It flipped over the y-axis. Why does it flip over the y-axis? Check that. Oh, great. That's a brilliant answer. Thank you. That's because only negative answers can work for this, right? I can't plug in 5, or 10, or 20. So I have to plug in negative numbers to make this legitimate, right? So that's why it flips over the y-axis. Now, but check this out. What if I change it, put that negative on the outside? Oh. What if I put it on the outside? That goes over the x-axis, because x needs to be positive, but y is negative. Y is negative in this case. So there is a difference in that case. What was the next one? 2 to the x power. Okay. So 2 to the x power. Now remember we did this in the previous unit. Like we did, negatives in front and it flipped over, right? But what if I put that negative next to the x? What do you think is going to happen if I put that negative next to the x? It's that. So you see how the red curve flipped over the y-axis. By the way, we have a negative exponent. What do we do with negative exponents? What do we do to the base? Yes, it's 1/2 raised to the x power. That's the decay function, right? That's a decay function. So it makes sense that we should flip over the y-axis, not the x-axis. Okay, what's the next one? Next one is going to be absolute value. Now, are we going to see a change for that one? Probably not, right? Oh, great. Got rid of all my crap. I got rid of all my previous entries. That's fine. I'll just do it again. So absolute value, you could do absolute value of x. And then let's do absolute value of negative x. No change. Because guess what? If I flip this over the y-axis, it's still the same thing, right? It's symmetric about the y-axis. There's no change. And the last one was, which one? 1 over. So that will flip over the y-axis. But also it's going to look like flipping over the x-axis as well. So that does flip over the y-axis, but also flips over the x-axis too. Actually, I should have put it next. There we go. Same thing. All right, so we'll go back to the notes, and that's actually maybe I might be able to get back to. Hold on. Yep, there we go. Oof. Okay, got back to it. So here we go. Here's how the graphs look. So this one looked like this. I'll do in red. Nope. That looked like this. That looked like this. That still looked the same. And that looked like this. And then I'll do the parent functions in blue. And to answer this question here, so look, same as f of x. Only that one. The rest all flipped. And again, you're flipping about the y-axis. We have negative on the inside. So that's another reflection we haven't talked about, but now we have. And it makes sense because you're changing the value of x, right? So now that's why the negative should go on the other side of the y-axis. Should. But this is not going to be symmetric absolute value. So the reason why that didn't, absolute value of x, it's already symmetrical about the y-axis. Okay, let me go and clear the screen. Let's move on to 95, guys. Okay, so what I'll do is I'll do the first 3 questions. I'll have you guys try the other 6, see how it's going. So you're asked to write equations for each graph. So you kind of want to guess what the equation would be. So for example, these are not the equations, by the way. These are the parent functions first. So y equals 1 over x, y equals x squared, y equals x cubed. Those are the parent functions. What kind of shifting happen in A? How far do we go to the left? So you're going to say y equals 1 over x minus 2. Sorry, x plus 2, my bad. What happened in B? What do you guys think? How many units down? 5. Good. What happened in C? How many? Do we go right? And how much? 1, 2. Yeah, I say 3. Okay. So what I did for this problem here, in orange, I wrote the parent graphs. Like, remember we talked about the parent graphs last time we met, which was actually yesterday. Remember I showed a little Star Wars schematic and then the schematic of the functions. You gotta know the general functions. Okay, that's 1 over x, part A. Part B is a product x squared. Part C is a cube of y plus x cubed. So you gotta know those general functions well. But then how do they change in the parent functions? X clearly went 2 left is x plus 2. X clearly went 5 down, x minus 5. X clearly went 3 right, x minus 3 squared. So x minus 3 cubed. Here's what you guys do in your table groups. Do D, E, F, G, H, I. So do the remaining 6. I'll give you guys probably 2 or 3 minutes. Shouldn't take very long. So around 150-ish, I'll check in, make sure you guys got it. Try D, E, F. Try come up and G, H, I. Come up for those 6. I'll share my answers, and then we'll move on to the next problem. Okay. I'm going to freeze my screen, write the answers, and then I'll share in a few minutes. We got to start on your table groups, okay? Yeah. Ease a line, yeah, totally. That's it, yeah. It's a line, yeah. Ease a line, guys. Yeah, I'm going to label each of these also. You got DJ Moore tonight, Jack? Jack, you got DJ? Yeah, he does. All right. Okay. Let me check. I'm checking you guys see how it's going. Maybe I want to divide it.
Okay, this is a. Let's see what kind of thing it is.
Sure. So Evie's got yeah, we're looking good. Yeah.
Would this one be negative?
Yes.
X?
Exactly.
Yeah.
So.
Sorry, is that? Well, it was a big one. Yeah, and it was something like, yeah. Like for that, I can't say. Like that's. You're not gonna do it, like. I used to catch those things that read just how it's like.
How do you know that?
So, but like love themselves. Can I go? I don't know. You're going 3 left, 6 down. You're going 3 right, 6 down. Just like that.
Where am I? There. You know, I didn't go walk.
The next one's the ones that got to the next one.
Well, I knew that was.
Yes, yes.
Okay.
Okay, you guys wish for the answers, because we gotta keep moving.
Let me unfreeze my screen. Here we go. There we go.
So just to recap, D is exponential, E, next quiet please, E is linear, F is cubic, G is quadratic, H is quadratic, I is back to cubic. Clearly, the exponential went 3 down, and 2 to the x power. How do you know it's 2 to the x? I mean, I kind of took a leap of faith, but if I plug in 1, I do get -1. So I kind of got lucky there, I suppose. E actually just a line, so don't overthink it. I know you're going to overthink it because we've been talking about shifting graphs, but slope is 3 if you count it. Line stuff -6, just look at it. So cubic, I went 2 left, 3 up, there we go. And I went 3 left, 2 down, there you go. G and H are both quadratic. You went 3 left, 6 down for G. You went 3 right, 6 up to H, and you flipped as well. So you put negative up front.
Wait, listen, what's
Yeah.
What's the?
Oh, this one right here? X plus 2 cubed plus 3. We went 2 left, 3 up.
All right, let's keep moving, guys. We got about 10 more minutes, so we got lots to still do. All right, guys, quiet, please. Guys, I need you to focus. Got to finish strong here. I know we're almost done today. Think about the parent graph for y equals x squared. Write the equation that will be the same as the parent graph, but shifted 4 units to the right. Oh, interesting. Okay. So write the equation will be the same as the parent graph, but shifted. Oh, okay. I got it. So you got to do this first, right? But here's the deal. That equation, I'm not sure what they wants to do with this problem. Hold on a sec. But shifted 4, that will be the same. But shifted 4 inches to the right. I'm not sure what they want us to do. Oh, wait. No. Yeah, I'm not. Yeah, guys, let's just skip this problem. I'm not sure what's going on with this problem. Guys, let's cross it off. I don't know what's going on with 102. Let's move on to the last page. All right. So let's go to 105. All right. Now, guys, quiet, please. Write the equation of the parent line of the parent graph of a line just y equals x. And if you think about it, what have you learned about transforming parent graphs to write the general equation of transform line? Well, m is the slope that's like a. B is the y-intercept that's like k. Because when you have the equation of line y equals mx plus b, that's a stretch if you think about it. You're stretching the line. And that's a vertical shift. Because you're going up or down at the y-intercept. So if you think about a line is just like most of those that we've done. It's just that the M is now a vertical stretch, and the B is going up or down. So this one's pretty easy. I mean, I think you guys know what to do here. Y equals 4/5 x plus b. And how would you solve for b? What would you do? Go ahead, Jack. You're saying something? Perfect. Yeah. Yeah, or you can just do that too. Which should be 33/5, I think. Yeah. So y equals 4/5 x plus 33/5. Yep. Okay. But again, a line is the same exact thing.
A line is the same exact thing as what we've done. M just happens to be a vertical stretch, B is like a vertical shift.
And I know you guys can find the equation of lines, not worry about that, but you guys sometimes just kind of get in a very rote kind of process, just do it. But you could treat it the same way like we've done all the other graphs. That's kind of the bottom line for that one. Okay, I'll give you guys a chance to copy before we move on to the last problem. Actually, I'll get the last one set up. So the vertex is 2, 3. So we're going to start with this, right? And I'm just going to move my screen. I'll shift everything up. Don't worry. There we go. Lovely. Okay. So last one, 127. Let's finish strong here. What's h and k here, guys? What's h and k?
2, 3.
Perfect. X minus 2 squared plus 3. And how would I solve for a?
Like 0, 0 and the equation.
Totally. 100% correct. Very nice. So 0 equals 4a plus 3. A should be negative 3/4, I think. So the equation's easy. Now I got it. Y equals negative 3/4. As it should be, it's going down. If you have 2, 3 as a vertex and 0, 0 is another point, it's going to be pointing down. So as it should be. Should be negative for A. And I'll just highlight it to indicate I got the final answer. Yeah. Okay. I think that concludes
The notes for test. So homework's on the back side. So if you want to do homework, later today or whatever. Yeah, so we'll set. It's ready to post to school as well. Yeah. Oh, guys, schedule.
Let's talk about what's going on for class this month. Okay.